Welcome to my today's lesson. This is your tutor, Mr. Ngatia, and today I want to actually introduce something different from what I've been discussing in my previous lessons. And whatever I want to introduce today is referred to as or called algebraic expressions. Algebraic expressions. Algebraic expressions. Algebraic expressions. Good. So algebraic expressions, we have two types. We have what we call linear and quadratic. For example, I can say 2x minus 1. This one becomes a linear expression. And the word linear comes from what we call line. So linear line, that means this can be an equation of a line. So linear expression. So algebraic expressions can either be linear or quadratic. And if we talk about linear, we are referring to an equation like 2x minus 1, which can be an equation of a straight line. So it gets called a linear expression. But now if I have something like x squared minus 4, or I have something like 3x squared minus 2x y minus y squared, or I can have something like 6x squared minus x minus 1. So all these ones, with the first part having a square, and even maybe the last part having a square, and even actually having something of this sort, are all referred to as quadratic expressions. Quadratic expressions. Quadratic expressions. Good. Quadratic expressions. And everybody knows that a linear equation should be in the form y is equals to mx plus c. Something quadratic should be in the form ax squared plus bx plus c. So linear, referring to the equation of a straight line. Quadratic, ax squared plus bx plus c. Good. So having understood that, there are possible ways in which someone can get asked not to draw a graph, but now to be able to get given some questions where the student is supposed to solve some questions in as far as this part is concerned. Some of these questions are as follows. I'm going to use quite a good number of these questions to be able to introduce this concept so that you can be able to understand what is literally the difference between a linear equation like 2x minus 1, or the equation of a straight line, and a quadratic equation with x squared appearing at the beginning. See? Because generally, a linear equation to be in the form y is equals to mx plus c. A quadratic equation should be in the form ax squared plus bx plus c. That clearly gives the difference between these two. So if I get given a question of this type, how do I solve this question? For example, I'm going to use question 6. And the question reads, simplify x minus 2 over x plus 2 minus 2x plus 20 over x squared minus 4. Now I'll come here and write the question down, and the question reads, just a minute, the question reads x minus 2 over x plus 2, then minus 2x plus 20, then over x squared minus 4. So this is the question just been written down. X minus 2 over x plus 2 minus 2x plus 20 over x squared minus 4. So how do I actually do this question? The first thing I'm supposed to actually ask myself is that these ones are in their simplest form. That means x minus 2 then x plus 2 are in their simplest form. Then 2x plus 20 and x squared minus 4 can further be simplified before I can be able to actually consider this negative sign. So I can just rewrite x minus 2 over x plus 2. Then I say minus, I can simplify this and say 2 into x plus 10. So 2 times x, 2x, 2 times 10, 20. And I say over, look at this last part, x squared minus 4. So literally, you're supposed to know that there are some laws of what we call quadratic laws. One of those laws says a minus b, then a plus b. When these ones get opened quadratically, when the brackets get opened, the answer must be a squared minus b squared. So a minus b multiplied by, if I may put this one here, a plus b, the answer must be a squared minus b squared. So looking at this part, we can apply that concept. Whenever you get an expression of this type with only two variables, such that all these ones can be able to get handled out in as far as finding the square root of every part is concerned, then please apply this concept. Then what do? You're going to write down x squared minus 4. Then how do I do this one then? I'm going to say the square root of x squared is x. Then I say minus. The square root of 4 is 2. Look at that. So this one is the same as saying a minus b. Look at that. Then I'll come down here and be able to say, if this has been written with a negative sign, that means I can rewrite this with a positive sign. So it becomes a plus b. They resemble. Good. So x minus 2. So the square root of x squared, x. The square root of 4, 2. So x minus 2 is the same as a minus b. A minus b. Then times. Then the square root of x squared, x. The square root of 4, 2. But this time around I use a positive sign because of a plus b. So I have a minus b, x minus 2. Then a plus b, x plus 2. So I can rewrite this expression in form of this. Good. So I'll come back to my question. I'll rewrite the question down now with this. I'm going to write down here, instead of writing x squared minus 4, I'm going to write x minus 2, then x plus 2. Good. So I've actually been able to simplify that. So I'll write down and work out the question. So I'm going to say x minus 2 over x plus 2 minus 2 into x plus 10, close the brackets, over x minus 2, close brackets, then x plus 2. This is the same as x minus 2, x plus 2 is the same as x squared minus 4. 2 into x plus 10 is the same as 2x plus 20. If I'm done in that part, I'm supposed to look for the LCM of this and this, because there's this sign of minus here. Whenever there's a minus or a positive, we always have to look for the LCM. Good. So I'm going to draw something of this sort. Let's look at that. Then I can ask myself, this x plus 2, this is x minus 2, x plus 2. Let me just give you an example here. You see, you may have something, let me just use an example like 1 over 3. You see, then plus 1 over 6. Then I have to look for the LCM. You see, this is the same as saying, so that you can be able to understand what I'm trying to say. 1 over 3, then I say plus or minus, any can work. So minus or plus, can use your minus for the sake of having uniformity. So I'm going to say 1 over 3 minus 1 over 2 times 3. Look at that. X minus 2, x plus 2. I have to actually relate it to this one, 6, 2 times 3. Because x plus 2 is here, x plus 2 is here. So I'm assuming this is actually 3. You see? Then I'm assuming the whole of this is actually 6. Look at that. So I can break this 6 down to have 2 and 3. So I have the 3 here, I have the 3 here. In other words, what I'm trying to say is that the LCM of 3 and 2 times 3 is actually 2 times 3. Because 3 actually can go here. How many times? 2 times. So that means the LCM of 3 and the LCM of 2 and 3 is actually 2 times 3. Look at this. This is x plus 2, x minus 2, x plus 2. The LCM of the whole of this and this is the whole of this, because this can go here, x minus 2. So I'm going to have x minus 2 over x plus 2. Then I say minus 2 into x plus 10, close the brackets, over x minus 2, x plus 2. So how do I get the LCM and be able to arrive at the final answer? So I'll come here and say x minus 2 over x plus 2 minus 2 into x plus 10, close the brackets, over x minus 2, then x plus 2. So I'll draw this line and be able to get the LCM. Now I've told you that if I have to use the aspect of this, look at this. This is 3, this is 2 times 3. I am taking x plus 2 to stand for 3, you see. Then x minus 2, x plus 2 to stand for 6. So I can break down this 6 to have 2. So this means 2 stands for x minus 2. Then 3 stands for x plus 2. So if these have to be related with this one here, that means the LCM of 3 and then 2 times 3 is actually 2 times 3. The whole of this gets taken to be the LCM. Here, x plus 2, then x minus 2, x plus 2. The LCM of this and this is the whole of this. The LCM of this and this is the whole of this. Good. Now I'm coming back here to say, now the LCM of this and this is actually x minus 2, then x plus 2. You see, so this goes into this how many times? X minus 2. Because this and this will cancel. What remains? X minus 2. So I'm going to say x minus 2 now gets multiplied with this. Okay, so that means I'm going to have x minus 2, this one here, then times this, and I'm going to have x minus 2. Okay, then minus. I can even be able to now come here and say this goes here. How many times? X minus 2, x plus 2, x minus 2, x plus 2. It goes there once. So I take this times this. So I'm going to say 1 into 2 into x plus 10. Great. So I can be able to open this by multiplying these 2. I'm going to have, you see, this is the same as saying this is actually able to get to that point of getting referred to as x minus 2 squared, if I'm not wrong, because it's x minus 2, x minus, the same as x minus 2 squared. So minus 1 into, I can be able to open the brackets here. I'm going to have 2x plus 20, because 2 times x is 2x, 2 times 10 is 20. Then I'll say over the LCM, x minus 2, then x plus 2. Okay, so I can move forward and be able to open the brackets here. So I'm going to say x minus 2 squared is, you say x squared, that gives you x squared, minus, then you say 2 times 2, 4. 4 times x, 4x. Look at the way I'm doing it. X squared. Then 2 times 2, 4. 4 times x, 4x. Then I say 2 squared. Of course, a negative sign getting squared gives you a positive number. So that gives me 4. Then minus, I open the bracket, minus affects the positive sign. So that is minus 2x. Then minus, and this positive gives minus 20. Then over the LCM, x minus 2, then x plus 2. I'll collect the like terms here. I'm going to have x squared, then minus 4x minus 2x. This gives me minus 6x. Minus minus. Look at this. A debt of 4 shillings, a debt of 2 shillings. That gives me a debt of 6 shillings. Then plus 4 minus 20. A debt of 20 with 4 shillings in the pocket. So I actually made a debt of 16 shillings. Over x minus 2, then x plus 2. So I have to actually solve this quadratically for me to arrive at the final answer. So I can just take it somewhere here. I can come here and say x squared minus 6x, then minus 16. I can use sum product factorization method. So the sum is this, negative 6. The product is this, negative 16. Two numbers, when you multiply you get negative 16, when you add you get negative 6. That is obviously to say, for example, which numbers do you multiply to get 16? We have 2 and 8, we have 16 and 1, we have 4 and 4. But obviously, there's no way in which you can add 16 and 1 to get even negative 6. That is even just impossible. 4 and 4 cannot as well work, you see. So you are made with 2 and 8. Of course, 2 times 8 is what? 16. But actually, the product is negative. That means one of the numbers must be negative. And if the sum is negative, that means the bigger number becomes negative. So 2 times negative 8, negative 16. 2 plus negative 8, negative 6. So I can come here and say x squared, now minus, or you can say first plus 2x, then minus 8x, then minus 16. So common divisor x into x plus 2, close the brackets, minus common divisor 8 into x plus 2. Why do I put here positive and there's negative here? Because negative times positive is negative. If I put here negative, it will be negative, negative, positive, which is wrong. So negative times positive, negative. Negative times positive, negative. So I can be able to now have x minus 8, good, x minus 8, then x plus 2. So I'll bring it here. So this has to be taken here. It has to be taken there. Because we took this, brought it here, we have worked out and gotten this one as the expression. You see? So you have to take this and actually replace the whole of this part with that. So we are going to have x minus 8, then x plus 2 over x minus 2, then x plus 2. That is actually to say that this and this will disappear because they are similar. Then what do we have at the end of the day? X minus 8 over x minus 2. Very good. That's what you're supposed to do. This one becomes our simplest answer, that you cannot be able actually to factorize further or be able to simplify. That one becomes your final answer. Thank you so much.